It's simple mathematics. Check it out. I revolve around science.
What are we talking about here?
Okay, some of us maybe still having a little bit of difficulty with finding the algebraic expression looking at a pattern. So I'm going to use the extended table of values to helpfully illustrate where the parts of the pattern come from and how this helps us to create the algebraic expression. So you can see here that I have a pattern, all right, and I've got one green block and three white blocks, and then that same white green block, and then three more white blocks, and so on. Okay, so if we look at this pattern, we end up with three blocks, and then we have the first three, and then the next three, and then we have the next three, the next three, and the next three, and then we have this one block here. Okay, we have this one block here. All right, so we can see that in our first pattern, our first number, we have 4 blocks, and then our second, we have 7, and in our third, we have 10. Okay, so what that looks like here is if we look at any number, okay, and we say, okay, what would it look like before this pattern? So what would it look like before we added the 3? Well, it might look something like this, okay, before we added the 3. So if we take that as the 0, okay, 0, and then 1, 2, 3, we can see how it starts to create the pattern. Okay, so if we look at the 0 here, we can see that we have one green block. So I'm just going to put that over here, and you're going to see why in a second. Okay, and then if I have my term numbers here, okay, I can look at them sort of in a pattern this way. Okay, now if we have our our 0 term here has one green block, so we kind of attribute that to 1, a value of 1, and we can see that that exists in all of them. Okay, and then we have in our in our first picture here, we've got a value of 3 green blocks, and then that one green block, all right, for a total of 4. And then in our next picture, we've got 3 plus 3 white blocks, and then we've got the one green block. Okay? And then in our next picture, we've got our 3 plus our 3 plus our 3 green blocks, or white blocks, and then our one green block. Okay? In our next one, we've got our 3 plus our 3 plus our 3 plus our 3 new ones, what we'd have after this one. Okay, and then our green block. Okay, so if we look at that, this becomes basically 0 plus 1 for one green block. Then we have 3 plus 1, so if I just kind of get a line going across here, and then this goes with this, just so you can see where my ones are coming from. Alright, and then we have this here. So now we have this, this, this. Okay? So for the total number of blocks, if we think about it, we would have one block here, then we would have 4 blocks, and then 3 plus 3 is 6, plus 1 is 7 blocks, 3 plus 3 plus 3 plus 1, which is 10 blocks, and 3 plus 3 plus 3 plus 1, which is 13 blocks, okay? All right. So we can kind of see that pattern. All right, but we keep, as we would extend this pattern, we would keep writing 3, okay, each time. And that doesn't become very efficient. So we need to figure out a rule that's going to allow us to not have to write these 3 this many times and help us to solve any problem. Okay, so if we kind of go past this, all right, if we go kind of past this, we seem to be writing this 3 each time. Okay, so in each pattern we can see that we have what we call the coefficient happening in each one. So the coefficient is kind of going to remain the same. We can use the coefficient in a pattern to help us solve the pattern for each one. Okay, and then we can kind of figure out how we can use that coefficient to our advantage. Okay, we also notice that we have that little green block there every time. So we need to make sure that we include that. So I'm going to just give it 1. All right. Okay. Now, I want you to look at the number of 3's that we see in each term. Okay, so that was the goal. So how many 3's do we see in the 0 term? Well, we see 0. So if we put that over here, we have 0 groups of 3. Okay, and then if we look at the next term, we have 3 green blocks. So if you come up here, there's your 3 green blocks. So we have 1 group of 3. In our next term, we end up with 2 groups of 3, and there's 2 groups right here. Okay, and then in our next one we have 1 group, 2 groups, and 3 groups, which is visible in our picture here. So we can see that we have 3 green blocks. And then if we were to do the 4th, that would continue, and we just put another 3 on top. So we'd have 1, 2, 3, 4. Okay, so we can have 4 groups of 3 blocks. Okay, so really, if you do this math, this is going to equal 3 times 0, right? Because we know that this is multiply. All right, when we don't see any sign, it's multiply. So 3 times 0 is 0, plus 1 gives us a value of 1, and there we see we have that. Okay, and then 3 times 1 is 3, plus 1 gives us the 4. So this equals 4. This is going to equal 7, and then this is going to equal 10, and then 13. Correct? Which is what we have in our number of blocks. Okay. Now there is a pattern. Okay. So if we notice the numbers in this row over here, and maybe I do it a different. I'll do it pink, for instance. Maybe the numbers in this row are very similar, well, they're exactly the same as the groups of 3's that we had in each one of the patterns. So if we think about it, if we are trying to make a rule, it looks like we would multiply the groups of 3, or the number of 3's, by the term number here, because that's exactly what we're doing over here to get the evaluation. Okay, so if we take it as any term, okay, we've just put in a variable to represent any term, hold the place of any term, we can find the algebraic expression by saying we're going to take the coefficient of 3, the increase, the change in each one, and we can multiply that by any term in the sequence, and then whatever we have that we started with here, we have to make sure that we add on, which we did here. In this case, 3n plus 1. Okay? And we call this the constant. Okay, so that's how you can see how we can build an algebraic expression using this extended t-table. Okay, now what that's going to look like if we draw a regular t-table, we will notice that we have 0, 1, 2, 3, and we have 1, 4, 7, 10. You're looking at how you get from 0 to the value. How do you get from the term number to the term value? Well, you multiply the term number by the coefficient of 3. So we multiply the term number of n by the coefficient of 3, and then we add where it starts, which is right there. Okay? Alright? The coefficient comes between each one of these values. So there's the coefficient. The term number goes in right here, and we end up with the algebraic expression. So hopefully you can see that the pattern that exists using this extended t-table and where the algebraic expression comes from.
It's simple mathematics. Check it